Today we're going to be talking about graphing systems of linear inequalities for the second day. And for these, just remember, this means that we have two or more inequalities with the same variables, and the solution is any point that makes both of the inequalities true. Our steps are going to be to graph the first inequality in shade, graph the second inequality in shade, and then state one solution and one non-solution. So in order for these inequalities to be graphed, they do need to be in y equals mx plus b form, slope-intercept form. And yesterday they were all ready to go for us. Today we're going to look at some questions where they're not necessarily ready to go. So if we have x plus y is greater than -3 and -2x plus y is less than 4, we're going to go ahead and graph these. And I'm going to use two different colors again. So if we have x plus y is greater than -3, that's not ready for us to just graph quite yet. So in order to get y by itself, we need to subtract x from both sides. We have y is greater than -x minus 3. And now that we have y by itself, we're going to figure out what our m is. So it's going to be -1/1, and our b is going to be a -3. So we begin with b, and then count our slope of down 1, right 1. You can do that a few times, and then you can also go the other direction, making as many points as you want, or at least 3, so we can make a more accurate picture. Okay, so now that we have this, we're going to connect these dots with a dashed line because it is just greater than. And if y is greater than -x plus 3, we're going to shade that one above the line. Doing the same thing for the second inequality. So here I'll use blue. So we have -2x plus y is less than 4. Y is not by itself. We can't just graph it. So we need to move the x's. That's the first step in most of these. So we have y is less than 2x plus 4. And since y is by itself, we're now able to say that our slope is 2/1 and our y-intercept is, a positive 4. So we're going to begin with b and then count the slope of rise over run. So that should be enough points. And once we have this, we're going to go ahead and connect the dots again. This one, since it's just y is less than, we're going to once again have just a dashed line in here. And then since it is y is less than, we're going to shade below the line. Okay, so remember that your solution area is going to be where both of those shadings happen. We want a solution and a non-solution. Easiest point to look for is 0, 0. This point right there, is that in the shaded region for both of them? Yes, it is. So 0, 0 is a solution. There are obviously lots of other ones as long as you're choosing anything in this area. Can we choose any point that's on like this? It's not a nice easy point, so could you choose that one? Could you choose any point that's on either one of these lines? So no, you can't choose any of those because they would as solutions because they're on dashed lines. So any of those could be non-solutions. I'm going to go over here where there clearly is no shading at all, and let's say -1, 2, 3, 4, 5. -5, -1 is a non-solution for this. Again, that's just one of many non-solutions. Alright, let's take a look at one more. Here we have 3x plus 6y is greater than or equal to 12, and 8y is less than or equal to -10x plus 24. So, alright, if we have 3x plus 6y is greater than or equal to 12, and we have to get y by itself, our first step again is to move the x's. So we have 6y is greater than or equal to. Those things, again, not like terms, so we just leave it as negative 3x plus 12, putting the x first. And then we're going to divide each term by 6. So that means we would have y is greater than or equal to negative 1/2 x plus 2. And you don't have to simplify that fraction of negative 3/6, but it definitely helps. Alright, so we're going to have our m for this is negative 1/2, and our b is a positive 2. So we're beginning with b, and then we're going to count that slope. Since it's negative, remember it should look like it's going downhill. You can kind of make as many points as you want along the way. Okay? So once we're here, since its y is greater than or equal to negative 1/2 x plus 2, we're going to connect these with a solid line all the way through the graph. And its y is greater than or equal to, so we're going to shade above. For the second inequality, we have 8y is less than or equal to negative 10x plus 24. To get y by itself, the x's are already moved over, so that means that we just need to divide each term by 8. So we have y is less than or equal to negative 10 eighths is going to simplify to be negative 5 fourths. Keep the x, and then 24 divided by 8 is 3. So here we're going to have that our m is negative 5 fourths, and our b is a positive 3. If we begin at b, and then we go negative 5 fourths, and I'll go up and over to the left as well. Okay, what type of line are we going to be using to connect this? So it is going to be solid. And here we want y to be less than or equal, so we're going to shade below this line. Let's see here. Kind of shade this way so you can see the difference with them. Alright, so we've shaded below that line. Now we need a solution and a non-solution. You only need one of each for this. So easiest point to look for is 0, 0. That's in the blue shaded area, but is it in both the blue and the red shaded areas? So it's not. So 0, 0 is going to be our non-solution, or an example of a non-solution. And then a solution is going to be anything in this area that keeps going here. So if we say negative 3, 5, that point right there, that is a solution because it's in the shaded area of both of them. Could you pick a point where they cross? Again, not so nice and easy. Or could you pick a point that's on one of these lines? Yes, you could, since they are both solid. So just making sure that you need to get y by itself first by moving x's or dividing by the coefficient of y before you can go through our exact same steps from yesterday.